Well, welcome to this online revision session for AQA FP2. We're going to cover the January 2011 question 4 on the topic of hyperbolic functions. Two parts to this question. First part gives you an equation relating y and x, that y equals 12 cos x minus 8 sin x minus x. And we have to show that this has only one stationary point. Well, we know that to find a stationary point, dy by dx has to equal 0. And so from that we should be able to find out the value of x at that particular point. And then we have to find the y value, so for that particular coordinate, and then show that there is a relationship between x and y. Remembering for the cosh function, some key results we need to know is the forms of cosh and sine in terms of e to the x, and that the differential of cosh and sine, that they're each the differential of each other, and maybe we might need the inverse cosh function or sine function, depending on how things work out. Okay, well, let's look at part A of the question then. As we said, to find a stationary point, we need to find the coordinate when dy by dx is equal to 0. So the first thing we need to do is to define dy by dx. And we said the differential of cosh is sine, so this becomes 12 sin x minus 8, and differential of sine is cosh. And the differential of x, of course, is -1. Now that equals 0 at the stationary point. Well, to solve this equation then, we will need to substitute in the fact that sine is e to the x minus e to the minus x over 2, and that cosh is going to be e to the x plus e to the minus x over 2 minus 1 equals 0. So what have we got in total there? Well, we can see that we've got therefore 6e to the x minus 6e to the minus x, and then we'll have minus 4e to the x minus 4e to the minus x minus 1 equals 0, which will give us, well, that's going to give us 2e to the x minus 10e to the minus x minus 1 equals 0. So if we then multiply through by e to the x, this will give us e to the 2x times the 2, and then you're going to get minus 10 and then minus e to the x. So we should recognize this as being a quadratic in terms of e to the x. So we are solving a quadratic equation here, and we're fairly hopeful that this will be something that will factorize. So I'm going to guess we put 2e to the x in that bracket and e to the x in this bracket. We've got to create a negative 10, so that could be things like negative 2 and 5 or negative 5 and 2, but bearing in mind we need a negative e to the x, I think that's probably going to be a negative 5 in here and a plus 2 in here, so that when that bracket is multiplied out we get our 2e to the 2x, we get negative 5e to the x and a plus 4 with the 2 times the 2, which will give us just a negative e to the x, and we got the negative 10. So that's factorising, and so that is then going to give us either e to the x equals 5 over 2 from that first bracket, or it gives us e to the x equals negative 2. But of course you should know that e to the x is always positive. You know the shape of the graph, and so this one is not going to give you a solution. It's not possible to be equal to that value. And so we only have one solution, that e to the x equals 5 over 2. So that tells us that x is equal to, well, the inverse of the e function is the natural log, so it's ln of 5 over 2. Okay, and that's worth a total of 7 marks. So where's our 7 marks going to come from? Well, initially we've got the fact that there is 1 mark for being able to differentiate this correctly. For then using an appropriate method by substituting the forms of cosh and shine will give you a mark. For obtaining this appropriate expression in terms of e to the x and e to the 2x gives you a mark. For then factorising the expression, you'll get 1 for using an appropriate method and 1 for actually getting the right statement at this point. And then for eliminating one of these results and obtaining the other one correctly, you'll get a mark. And then finally, for getting the correct answer for the single stationary point, you get 1 mark. Okay, and I suppose really we should have said here, after we got x equals ln 5 over 2, this is the x coordinate of the single stationary point, just to make that complete. Okay, so the next part is then we've got to find a relationship between the x value and the y value at the stationary point, and they are suggesting that the x value is a and the y value is b. So we have already obtained then the value of a. We know that a, the x value, is ln of 5 over 2. So what we've got to do is then find the value of b, or at least an expression that involves it. So if we substitute that value of a into the cosh function and the shine function and x here, that will then give us the value of y, which is the b value. So b must equal, and again at this point, since we're substituting a is ln 5 over 2, it will make sense to use the cosh function in terms of e to the x and e to the minus x. So we know that the cosh function is e to the x. Well, if a is ln of 5 over 2, that will give us 5 over 2, plus e to the minus x. Well, if a is ln 5 over 2, e to the minus x is going to be minus, let's see, e to the minus x, so it's the e of the negative value of that, and since that's a log, that will give us the reciprocal. So that will become 2/5 all over 2. and then we got minus 8, and again it's e to the minus x, so that's 5 over 2, and now this is minus e to the minus x, so this will become minus 2/5 all over 2. Oh, apologies. And then at the end of there we got the x value, which is just ln of 5 over 2, or we could just write that as just a. Okay, right, so now all we've got to do is simplify this, so b must equal, yeah, so what have we got? We've got 12, that's divided by 2, so that makes 6, and that will be multiplied by 5 over 2 plus 2/5, so common denominator is 10, so 5 times 5 is 25, and 2 times 2 is 4, so that's 29 over 10. And then we got, similarly, this becomes 4 lots of 5 times 5 is 25 minus the 4, so this becomes 21 over 10. And as I said, that value at the end is actually the same as a, and so since we want an expression for a plus b, that would make more sense to put that in. So now I can take the a over to the other side, and all you've now got to do is to collect all of this together. So you've got 6 lots of 29, which is 174, and 4 lots of 21 is 84. Subtract 1 from the other, and you get 90 over 10, which of course is the same as 9, and hence the result that we require. So again, a method mark for an appropriate substitution in here, and an accuracy mark for actually simplifying that down. To getting to this point here, again, you'll get a mark, and then for finally simplifying that down to the result that you require will get you the 4th mark in this part of the question. Well, if you found that useful, further examples and support for your work can be found at the Further Maths Support Programme website.